Hello and welcome to lesson 3.2. In this lesson we're going to kind of introduce our first bit of graphing in this course. And yeah, we'll have several more lessons on graphing and different styles of graphing and ways to do some things better, but this is a good spot to launch off, especially as our last section, our last lesson, was on function notation. And remember, in part of that function notation, we spent some time relating inputs and outputs, x's and y's. If I have a function, if I could put in something and find the output, that's the same thing as having an ordered pair, an XY pair. Now, for a quick review, if you've never really felt confident in graphing anything, the x-axis runs left to right, these are the x values, and the y-axis runs up and down. And if I have a coordinate like this, an xy, so if I have a coordinate like 2, 5, it's simply telling you how much to move in the x direction. Whoops, I meant to write an x. Try that again. How much to move in the x direction. And this one tells you how much to go in the y direction. Remember, x directions are left and right, y is up and down. So from the middle, from the origin, from the 0, I have the point 2, 5. So I'd go in the x direction, positive 2, and the y direction, positive 5. 1, 2, 3, 4, 5. And then I can put that point and then double check that it is in fact at 2 in the x value, 5 in the y value, so I can plot points. Now to make a function, if I have all of its points, or at least a few of its points, I can start to get the feel for its shape. So say it's something like a straight line. I get enough points. Oh, okay, that was a horrible attempt at a straight line. I get enough points. Maybe I'll cheat and just do 2 and just do a little short. Oops, didn't mean to erase that. If I have, okay, I still suck at straight lines. But anyways, if I have some of its points, enough of its points to kind of figure out what the shape is, then I can graph it without needing to get every single point on the line. Okay, but that's a really important understanding, is that all these points, every bit of green is a point, even if it's a decimal, is a point in whatever function or equation that we're working with. Okay. And so, what this means is, since this is inputs and outputs, if I did give you something like, well, we'll do it on the next page. If I did give you something like, say this, f of x equals 2x minus 5, or you could think of it as y equals, because I know we're still getting used to function notation. These are both the same. Well, then that means all I have to do then is get some points on the graph. Well, how are we going to do this? This is called a t-chart or an xy table. So all we're going to do is pick some x's, plug them into our function. So this can be f of x or y. I'll let you trade back and forth, whatever's comfortable to you here. All I gotta do is pick some x's, plug them in and see what comes out, and that would be an xy pair, a point, and then I can put those on my graph and see if I can figure out this shape and figure out where this thing goes and then draw it. And so I can graph any function in this way. There are shortcut ways to graph some special types of functions, and we'll actually learn better ways to graph, or faster ways or maybe less tedious ways of graphing lines or linear equations. That's the main tilt of this class, but I'll show you a few other functions, and we won't really dive into special ways, but guess what? In the next math class, you're going to dive really deeply into a lot of functions in these ones that I'm covering now. Okay, so let's start with this example. So I have this y equals 2x minus 5, or you can think of it f of x equals 2x minus 5. So what I need to do is pick some x values. Okay, and once I kind of figure out the shape of this thing, that'll determine how many x values I want. I'll go ahead and tell you, I know that this one is linear. Remember talking about our word problems where we had the total was equal to some number times x plus or minus some starting number, the rate and all that. Notice that I just have an x here. It's not got any exponent or anything like that. I know this one's going to be a straight line. If it is a straight line, I would like you to have at least 3 points. So I only need to pick 3 x's. You may pick good x's or bad x's. If you pick a weird x that gives you a decimal, just throw that one out and pick a new one. Now, to make this simple on ourselves, since we're picking any random x we want to, you could pick like 3,000, but then you have to do the math and graph and count out to 3,000. Why not pick some of the easiest things that you know how to do math with? I think I'm going to start with a 0. I'm really good at my 0 multiplication tables. And so if I just take the function and plug in a 0, Let's practice our good function plugging in here. 2 blank minus 5. And I would like to plug in a 0. Okay, 2 times 0, I can do that one in my head. I told you I was good at my 0 times tables. That is 0 minus 5. 0 minus 5 is negative 5. So the output, or the y value, is 5. So look, I just found a coordinate pair. An xy pair of 0 in the x direction. I forgot the negative. Negative 5 in the y direction. Negative 5, down 5. Boom! I have a point on this graph. Well, that's only one point. Let's do it again. What's another one most people know their times tables too? Ooh, how about their ones? That one does not take much calculating. So let's plug in a 1. F of 1 equals, let's see, what's the function? 2 blank minus 5. 2 blank minus 5. And I am plugging in a 1. So 2 times 1 is 2. 2 minus 5 is negative 3. So I have the point 1, negative 3. Nice. I have this ordered pair. If you wanted to write the ordered pairs out to the side to make it feel more intuitive for graphing, 1 in the x direction, negative 3 in the y. So 1 in the x direction, negative 3 in the y. And we got this point. Okay, white's not going to show up on that. I'm a dummy. Right here. And it is at the point 1, negative 3. Okay, I'm starting to see this. I told you it was a line. I think I could draw it, but I would like 3 points for a line to make sure we have a better better understanding of where the line's going. Why not keep the numbers simple and let's keep trying with something like a 2. Now, sometimes there'll be fractions in here and you'll try numbers and they'll give you fractions. I never want you to try to graph a fraction. So I never want you to use the point like negative 3.5, 1.24. Like, okay, we can't be exact with that. I want things right on what's called the lattice points, right on the whole numbers. So if we tried 2 and it gave us something nasty, you're picking these, just pick another one. Just try another one until you get a pretty number. So let's try 2. F of 2 is equal to 2 times blank minus 5. And we are plugging in a 2. 2 times 2 is 4 minus 5. 4 minus 5 is negative 1. So when I plug a 2 in, my output is negative 1. 2, so that ordered pair is 2, negative 1. Oh, that 1's kind of sloppy. Sorry. That is a 1. I might need to erase it and write it more neatly. We'll just do this instead of doing a fancy one. We'll just go with a straight slash. So let's see. 2 in the x direction, down 1. Okay, I think I'm seeing that these are lining up. The other reason for 3 points is if I make a mistake on 1 or 2 of them, these won't line up. Okay, and I will attempt to draw a straight line, but it's kind of hard on this thing to do that. Now, when you draw lines, I ask that you extend them well past the points because lines go on forever in both directions. Get at least close to the edge of your graph, and I put arrows on the ends of mine to let you know that it's going to keep going. So we just graphed our first thing. Now, this method of making a table and picking x values is the simplest method, and it works for almost anything. Anything that you can plug in values and get an output to, you can graph it using this. Now, you may need a lot of points to get the shape of it, but that's really great. This is your fail-safe. Whenever you don't know how to graph something, make an XY table. Okay. Now, sometimes it's not as pretty. So notice this one's not y by itself. So we might need to make sure we have this skill of getting y by itself. So if we look here, I have y not by itself. I have a 4x and a 2 on the left side with it. So what we're going to do is treat this like we would if we were solving for, like when we learned last chapter, or 2 chapters ago, how to solve for y. I need to get stuff out of the way. So I have this 4x. Look out front. This is a positive 4x. We would like to move this whole x term. To move an entire x term, we add or subtract depending on what its sign is. So this is a positive 4x, so I shall subtract 4x from both sides. Minus 4x, minus 4x. Okay? Leaving me with 2y equals 10 minus 4x is 10 minus 4x because guess what? This has an x, this does not. They are not like terms. I can't combine them. So while this looks like we're doing some scary stuff, moving a term over with x, there's nothing to combine it with over here. All I'm doing is writing minus 4x over here. That's nice and simple. All right, let's get y by itself. So I need to divide by 2 on this side. So I need to divide everything by 2 on this side. Okay, notice I'm dividing everything by 2. 2 divided by 2 is divides out to 1, so it's gone. Y is equal to 10 divided by 2 is 5. Bring down your, well, negative 4 minus 4 divided by 2 is negative 2. And don't forget the x is with that. Okay, awesome. So there we go. We've got it y equals. That's usually where you like to start to be able to make your x, y table. So notice I didn't write this one as a function because it was not, we don't write f of x here. We only write f of x equals. So we could write it as a function now, but I think we can handle plugging in without using function notation. Let's give it a try. You want to try the same 3x values, 0, 1, 2. If one of them sucks, we'll just scrap it and pick another one. So let's see, if I plug a 0 in for the x, let's do the same good practice of rewriting it with a blank for the x, and I'm plugging in a 0 here. So that would be 5 minus 2 times 0 is 0. 5 minus 0 is 5. So the output here is 5. Nice, that wasn't too bad. Let's try a 1. Y equals 5 minus 2 blank. And we're going to plug in a 1. Let's see. 5 minus 2 times 1 is 2. 5 minus 2 is 3. Nice, so we got a 3 here. That wasn't too bad either. So one more time to get a third point. I know this one is linear because there's no like squares or square roots or cubes or third power or anything like that on the x. And I got a y and an x. This is nice and simple. So let's see. Y equals, what is it? 5 minus 2 blank. And what am I plugging in this time? I'm going to plug in a 2. 5 minus 2 times 2 is 4. 5 minus 4 is 1. Nice. Okay, so I got all these ordered pairs. This is the ordered pair 0, 5. This is the ordered pair 1, 3. And this is the ordered pair 2, 1. So we should be able to graph these 3 points. So let's see, 0 in the x direction. Let's label this x, y. 0 left and right, and up 5 in the positive y direction, so right there. Then I got 1, 3, so 1 in the x direction, 3 in the y direction. And then I have 2, 1, 2 in the x direction, 1 in the y direction. And there is my beautiful straight line, close enough with my drawing skills. Yours should look better than mine drawing on paper than drawing on this thing. All right, wonderful. If I could draw straight lines, it'd look even better. Okay, I think we're grasping this. So now let me kind of throw something at you. This should look even simpler, but wait a second. If I want to graph these are actually special lines. This works as well. We'll go and say, y equals 3. Okay, let's put an xy table, and we'll just pick some x's and plug them in. So let's pick some x's like we did, 0, 1, and 2. All right, y equals 3. There's nowhere to plug an x in. Oh my, there is no x involved in this equation. So I guess it doesn't matter. What is this telling you? This is telling you that all the y values are stuck at 3. So no matter what x value you have, your y value is 3. Everything's 3's. So if I plotted this point, 0 in the x, 3 in the y, 1 in the x, 3 in the y, 2 in the x, 3 in the y direction, I get a line, but look what sort of line I get. I get a line that goes straight across horizontal. So most people don't bother doing any sort of work here. They memorize this, and you can memorize that y equals a number is a horizontal line. Okay? And it's going to be at a height of 3, a horizontal line at a height of 3. That should make sense because this is saying all the heights. Remember, if you can interchange y values and heights and outputs, all the heights of every x value are at 3. Okay, now some people get these confused because the y-axis runs up and down. A y equals a number runs left and right, but that's because it's saying no matter what your x value, everything has the same height of 3. Does that make sense? Let's do the other one in red so we can tell them apart. So x equals negative 2. If you go to make your xy table this time, oh no, I can't really pick x's because what is this telling us? This is telling us all the x's are stuck at negative 2. These are stuck. Okay, the mathematical term is this x is constant at -2. It only can hold -2. Now the y's, do you see any y values in here, variables in here? Y can be anything. We'll just be lazy and go 1, 2, 3. So just pick some random numbers for the y's, and these are your coordinates. So -2 in the x direction, 0 in the y. So could you guess what type of line this is going to be? If y equals 3 is horizontal, I'm going to guess x equals a number is vertical, because every y value has the same left and right movement then. So back to 2, 0, -2, 1, and -2, 2. Yeah, that does in fact give me a vertical straight up and down line. I can't draw straight lines, but hopefully you can draw better than that. You can use a straight edge if you need to. So looky there. Now some people get that confused because of the fact that the x-axis is left to right, but then x equals a number is a vertical line. But what it's telling you is left and right movement, everything is moved -2. Every y value is negative, has an x value of -2, so it's all been shifted back 2. So it should kind of make sense when you kind of conceptualize it that way. I have two more examples I want to work with you, then I'll turn you loose. So we've been doing all linear equations, all straight lines, and I think that's not too hard, but this using a table of values things even works for nonlinear. So notice I have x squared here. Now I'm going to probably need more points, but let's take a look and see if we can do this. And we'll do some discovery, and I'll kind of make not a mistake, but kind of a little bit of not fully do this correct at first, and we'll see what's up with that. Let me move this somewhere so I have space to work. Okay, right there, that looks good. And so let's say we pick our usual 0, 1, 2, and we're going to plug these in. So f of 0, 0 squared. Okay, I didn't do good technique. Let me put parentheses so it's just x squared, so blank squared. 0 squared is 0. Okay, well that seems simple enough. We'll go ahead and put that on there. 0, 0. Nice. All right, what if I want to do 1? Plug in a 1. 1 squared is 1. Oh, once again, easy. 1, 1, boom. Plug in a 2. 2 squared is 4. Okay, so 2, 4. Okay, and you might think everything's been a straight line. Let me try to draw a straight line. And you're like, it's not quite lining up straight. Maybe I just made a mistake and I'll go with it. That's why we need more than 3 points for different shapes. I know this one's not linear because I have an x squared. Do you see that? Because of this, I actually know what shape it is. If my highest exponent is a square, my shape's going to be a parabola, or one of these U-type shapes. Now, if you don't know that, then we need more points to figure this out. And so anytime you see an x squared, I'm going to need more points. Let's do one more this direction. We'll go 3. If I plug a 3 in, you could do these in your head now, since we're just squaring them. 3 squared is 9. And so if we go 3, let's put the 9 here, 3 and 9. 9 is up here. And oh my, we see it's starting to get kind of steep. And so if you didn't plug in any more numbers, you might think, okay, I kind of see this weird curve shape. But because this is where you need to start learning things, because I have an x squared, I know this is this U shape, so I need to find where it turns around at. So this means I need to try some negative numbers to start going this way to see, does it turn around here, or here, or here, or is this the turnaround point? And it's called the vertex. Is this the vertex? Is this where it starts going back up? And so let's try some negatives. We're going to have to try numbers until we can find this. So let's try -1. If we plug in -1, -1 squared, oh, that's just 1. Okay, -1, +1. Oh, okay, I think I found where it turned around. Let's get at least 1 or 2 more so I can get the shape. -2 squared. Oops, that's kind of sloppy. -2 squared is +4. So we have the point -2, +4. Ah, yeah, okay, now I'm seeing this thing. We'll do one more just for good measure. But once you kind of know the shape, you might only need 5. The 1 in the middle and 2 on each side maybe is good enough. -3 squared is +9. Thinking about the next example already. -3, 9. Okay, so I'm going to attempt to draw a beautiful parabola. I'm already missing half my points. But there we go. So there's my shape. So I needed more points to see the shape that time. That's okay. Neat. So let's do one more that's not as simple as just x squared. It can have more to it. But what I'm going to need to do here is find where this thing turns around at. Otherwise, it'll, I might be here guessing numbers all day long. Let's make our XY table. So we can graph anything using this XY table. So let's, once again, we'll try 0, 1, 2 and see what we got. And maybe we will, I will try to maybe speed this up some instead of taking the time to slowly work each thing. If you're confused about any of the, oops, I forgot the 2. Any of the steps I take, just slow down and think about it and maybe grab a calculator and you'll see what I'm going to do is just do a lot of these in my head. And maybe I'll just be lazy and keep, I don't know. So if we plug a 0 in, let's see, 0 squared plus 0. So this is just going to be 0 plus 0 minus 3, which is negative 3. So negative 3. So we got 0, negative 3. Get that point. So let's try 1. So if I put f of 1, so I put 1 and 1. So let's see, that'd be 1 squared is 1 plus 2. So this is just going to be 1 plus 2 minus 3. So that's 3 minus 3. That's going to be 0. 0. So we got the point 1, 0. Okay. This is working out maybe. I don't know. We'll see if we found it. So let's try our 2. F of 2. So it'll be 2 squared plus 2 times 2 minus 3. And so 2 squared is 4, plus 2 times 2 is 4, minus 3. So that's 8 minus 3, which is 5. 8 minus 3 is 5, yeah. So we got 2 and go up 5. Okay. All right. Well, clearly I'm on this side of the curve, so we need to go into the negatives to see if there's anything going on. So we'll try f of negative 1. Bad out of space here. So we'll have negative 1 squared plus, oops, put the parenthesis in the wrong spot. That's okay. I put both. 2 times negative 1 minus 3. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 3. So this will be, let's see, 1 minus 2 is negative 1. And negative 1 minus 3 is negative 4. So if I plug in a negative 1, I'll get a negative 4. Oh, we haven't found the turnaround point yet. It must be slid somewhere over here. Okay, so what I'm going to do is I'm going to move some of this work out my way. I might just delete it. To keep working. All right, so let's try negative 2 then. We'll try negative 2. So f of negative 2. Negative 2 squared. 2. So what I'm doing here is trying to show you there are ways of knowing where the vertex is to save you time, but that's stuff you'll study in your next class in Math 111. We're just experimenting and playing around. This is not hard. It's not taking a lot of like brain power. It's just taking time to find this. So this works, but it might annoy some people that it takes so long. But let's see. I'm trying to prove a point here. Negative 2 squared is positive 4. 2 times negative 2 is negative 4. Minus 3. 4 minus 4, that's 0 minus 3. Negative 3. Oh, we may have found the turnaround point. So negative 2. Did I miss one somewhere? Maybe not. Negative 2. Negative 3. Okay, there we go. Couldn't find the point. We plugged in a negative 2, we got negative 3. Okay, I think we found the turn. Let's go one more to see if it's somewhere over here. So let's try negative 3. Last one, and this should give us the whole shape. And we don't need the rest to draw it, to sketch it. So squared plus 2 blank minus 3. Let me make sure I'm using my good function manners here. Plug it in a negative 3. Negative 3. So negative 3 squared is positive 9. 2 times negative 3 is negative 6 minus 3. Oh yeah, I feel good. So 9 minus 6 is 3, minus negative 3 is 0. And that looks beautiful. So now I should be able to attempt to graph this. A little bit difficult there, but I got it. There's our graph. Oh my goodness. So we can graph really funky stuff. We can graph really hard things. This is not a linear equation. These linear equations are easy. We only need 3 points and we can easily graph a line. But we can do other shapes too, just by making a table by plugging in x's and spitting out y's, just by doing some multiplications and subtractions and additions and things. I can easily discover all the points and draw any function I need. So next class we'll dive into even more functions, still practicing making Jews and t-tables. I'm not going to teach you any special way to graph this. That's what they focus on in Math 111 is you'll work on getting this converted to vertex form and finding the vertex, and it takes factoring and all that fun stuff. But you'll do that in your next course. So don't feel rushed. You feel excited to get there. But that's all I have for you today. So until next time, take care.